Okay. This is Verkle Implementers Call number 13 and issue 958 in the PM repo. We have a few agenda items today. Just a few, actually. Might be a quick call. After we go through some updates, Guillaume has some updates on the shadow fork, as well as the testnet. There is, if we have time and Pavel is here, we have agenda item that we did not get to last week, the proposal for code packaging. And last up on the agenda, we have Gajender on EIP 2935 block hash. So yeah, anyone have any updates they'd like to start with?
Yeah, I guess we'll start. Yeah, so there was a shadow fork. We're gonna talk about this in more details in a few minutes. That involved some reworking of the kurtosis tooling. So I think Pari's on holiday this week, so just mentioning that there was some DevOps work involved, and they did a very good job to speed things up, so that really helped. Otherwise, I'll let Ignacio talk about the investigation he did. Also, Ignacio worked on the replay, so if Ignacio, you want to say something about this. But yeah, just before bug, we were discussing with other teams to try to investigate bugs on the test net. I did some work on the transition tool for testing. So there was some back and forth with Mario, who's also not on that call today. I think at this point it's clear that we need to start working on. I'm saying Geth needs to work on the rebase of Verkle on top of Cancun, because we had the Holiski shadow fork working, now we need more data to keep testing, to keep pushing, and that will come with Sepolia and mainnet. And I think at this point it's clear that we need to get that. Otherwise, I think in the next week I will work on that rebase. It's not going to be done in a week, but at least make some progress on that. Because there are also some developments in Geth. On the Geth side, we're going to reactivate archive mode, hopefully in the next release, and that's a good point. That's a good moment to also integrate more Verkle code. And I want to start investigating the chunk fill cost that were part of the EIP 4762 that we're not integrating on the testnet currently. I don't think we should integrate it for the time being still, but I would like to spend some time on that. And yeah, Ignacio did two things, so I'll let him. I'll give him the floor.
Yeah, we get a quick update. So apart from some fixes that we did for Kaustinen regarding bugs that were present that we discussed in the previous call, I'm working on some have this replay chain, replay of importing a chain, now on rebase fixes that we did on Kaustinen in the last weeks. So there are some problems there I have to investigate. But apart from all these main stuff, I try to make some progress on trying to answer this question about if in Verkle trees we have a DOS vector regarding making a branch deeper than expected. All this was motivated by the block hash discussion, and if like using ring buffers is a problem or not, and things like that. So I think I just wanted to make some more I wouldn't call formal approach, but trying to see if this is really a problem or not and put this problem to rest. Hopefully, if we have to do something about it or not, because it's very confusing to people. If like developers have to do something about it, or we have to change the Verkle tree design in some way or not. So what I did, I will just talk very briefly about this because I don't want to get into details. I shared in the chat a HackMD document that I shared with Gottfried and Kev some days ago, so they didn't have much time to review it yet. But I got some feedback, and the idea here is to do some semi-naive attack on this kind of DOS vector, because like I think that the summary of this topic is that we have to answer two questions. The first one is, what is like a practical result that an attacker can achieve on producing a branch of a particular depth? So let's say that the expected worst case depth that an attacker can achieve is 13 or 15 or something like that. So we need like have an idea of what is that number. So that's one question. And the second question is, we need some idea from execution client teams if updating a branch of this depth is really a big performance hit for them or not. So I tried to answer both questions in this document. I did some kind of POC code to generate a branch of a given prefix, and I have some numbers on different CPUs, which are obviously not really that powerful compared to what an attacker could have. And also I created a benchmark for Geth to understand better how much time it takes to update the root of the tree on different branches with different depths, as to try to have a sensation of what kind of depths start to feel as somewhat uncomfortable. And I did this in two setups, one in my desktop CPU, which is a semi-modern CPU, let's say, and on a Rock 5B, which is like a really, really low hardware. Yeah. So the bottom line here is, I was just chatting with Godfrey that was giving me his feedback now, and it seems like a reasonable number to expect that an attacker can achieve is a depth of 13 or 16 in that range. So that's a good ballpark to have in mind. And now it's more like trying to answer the question if having branches of this depth is really, really a problem for clients or not.
Sorry, how do we get?
Yep.
How do we get 13 to 16? That's very high. Like, I mean, 10, a depth of 10 would be 80 bits. And I mean, 80 bits seems like a very, like, I think you can you can get higher using collisions, but collisions are not going to give you the ability to attack a specific address. You can create random ones that are deeper. Right. But if you want to attack a specific contract, say that stores this ring buffer, then you have to get a pre-image. And I would think that 10 would be hard. And I think like I expect like attackers to get at most to something like 8.
Right. I mean, maybe Godfrey wants to talk about this, but I think that was exactly his conclusion. I think that this 13 to 16 is considering a collision, not really like a specific target of address. So
right, but that is not relevant then to attack something that we want to store in a state at a specific address, right?
Yeah, correct. I mean, if it wants to attack a really hot branch, it shouldn't be like reasonable to expect that kind of depth. So yeah, I think that's a good point to clarify. So maybe like, yeah, a more specific attack to a branch is around 10 and 13.
Yeah, I mean, 10 is really is very, very hard. I think like realistically, like, yes, like if we want to be strict and say we want 128-bit security, then it could be up to 16, I guess. But like realistically, this is not like this attack is not gonna like bring down Ethereum. It's just going to make blocks slightly larger or slightly slower to process. So is someone going to invest trillions of dollars to attack it? No. Like I think like maybe we can like set the cap at $10 billion or something, and then I think like yeah, 10 is really the max that I could ever expect.
Cool. Yeah, I mean, this is exactly the kind of, let's say, conclusions that I was trying to find. So that's very helpful. I think it's still worth that each client does this kind of benchmark to see how big of, like, how much time it takes to update the root node on different branch depths, just to be sure, because get is maybe using a library is very optimized. But yeah, this is very helpful. I think Godfrey will
But are we
write
still
something in the
talking?
chat.
So is this still only about the block hashes?
Not really. This is like a more general concern.
Okay.
Yeah.
Oh, okay, I see. Because for the block hashes, I think it's not really a concern, like because we have to use that branch at most once per block, right? Because we can batch all of the transactions together. And so both the size and the access times are pretty bounded, I would assume.
Yes. Well, yeah, Godfrey is right in the chat, but maybe we can keep with the updates and jump back to this topic if you want to keep discussing.
Cool. Any other updates?
Yeah, hello. I can update for the Nimbus team. So on our side, the Constantine library, which includes all the math primitives for Verkle, is complete and is on par with Get. And in parallel, we are also starting the integration into the Nimbus client. Yeah, that's it. Thank you.
Yeah, I'll just give another reminder that the Pedersen hash, the serialized commitment method that we're using in Pedersen hash is being changed. This is a breaking change for, I think Nimbus needs to update, and I believe Nevermind. Everyone else, I've sort of pushed the branch or a PR to do the update.
For Ethereum JS, we have worked a little bit on developing a pre-image manager, which Gabriel, if he wants to talk more about. On Dorsa's side, I can also pick up the rebase to Denup so that I can support Guillaume in his rebase. And yeah, that's.
Yep, as Legendary was saying, we've developed a pre-images manager to be able to handle pre-images saving on the Ethereum JS client, which is necessary for the transition. We initially had a POC that through testing we noticed was missing some things that happen at the block level and not transaction level, like withdrawals, pre-images, as well as the Coinbase. So that's been addressed, and it will be merged into our production Ethereum JS client this week.
One thing while we're on Ethereum JS, we had a meeting, and I think one thing which is going to stop the full integration for Ethereum JS is the fact that proofs are being serialized on the Verkle tree sort of layer. I think it was brought up a while back. Are we ready to sort of only make proofs serializable and deserializable on the IPA, sort of on the cryptography layer?
So you mean like having opaque proofs?
Yeah, so only the cryptography can deserialize and sort of make sense of what it is.
Yeah, I mean, we could. It's just that it's such a nice tool to debug. I would rather push this as, yeah, make this change as late as possible. But we could. We just have to write something that deserializes. Like if you take Dora, for example, the Dora the Explorer, which is the Explorer we've got on the block Explorer we've got on Kaustinen. I just take the JSON and I dump all this information. Ah, right, but you mean the cryptography? That would only be the cryptography. Yeah, I guess we could do this. You would just need to provide a I don't know. Yeah, do you have a write-up of what you would like, and then we could make it happen, I guess.
I don't have a write-up, but essentially everything that we considered the proof is now just an opaque byte. So like CL, CR, like the things that I think wouldn't be considered part of the proof would just be like the keys and values, because the cryptography doesn't need to make well, it does use it, but I think Verkle also uses it, so that's not sort of considered a part of it. I can write up an issue for it just to be more concise.
Yeah, if you don't mind, then we can just refer to it and implement it.
Any other updates? Cool. Okay. Up next, Guillaume with the Shadow Fork update.
Yeah, so that's going to be very short. There was a shadow fork of Holiski. There's that was like the simplified version of it. We were not running any transactions, but it was about testing that we could perform an overlay transition with the right real life data. So it revealed a lot of issues, namely that there's a at least in Geth, but I'm sure in every other client, there's a reentrancy problem. You have on the one hand the miner that produces blocks, and on the other hand, you have the API engine that can potentially preempt and cause some issues. So this got fixed with a simple lock, of course, which is not as efficient as I would like, but at least the proof of concept is there. The more tests need to be done, more refining of the locking system needs to be done, but at least it's proven to be working. So there's a branch. It's a PR that's on Geth, on the Geth repo, or more exactly my Geth repo. That's called. I'll actually just copy paste the PR in the chat, but it's called Post Genesis Transition, and that's the branch that you want to look at if you're interested in looking at it. But there will be more updates to that branch as we keep testing shadow forks. Yeah, that's pretty much it, unless there are questions.
Cool. Did you want to keep going with any updates on the testnet as well, Guillaume?
Yeah. Right. So the testnet. So I will share my screen for this one. Where is the right? That's the window. So as you know, there's this page that describes the current specs and status of the testnet. So we found some bugs thanks to all those teams that tried to join it and get their clients to work with it. So the testnet is currently at 10 times what other teams have reported bugs at least. So I assume most clients are actually just 10% of the way. I mean, I'm happy to be wrong, of course, but I think that's my understanding. and we had some bugs. So we fixed none of them on the testnet. They will all be fixed during the relaunch. I think currently it's quite valuable to keep this current testnet running and finding more bugs, namely because Adrien from Open Zeppelin has released his he's got a lot of test contracts that he has deployed around block 70,000. So I would like to encourage people to try to keep syncing, even though they see bugs. At least they are understood. They are being fixed. I could go over them. There's one. So two of most of them have been fixed already in the branch. So it's just awaiting a redeploy. We have two. One of them is understood, but Guess has no fix for that. But it's well understood. And there's a new one that has been reported by Gabriel from Besu this morning. And I'm still there's an understanding. It seems to be stemming from the fact that Geth will not when it's coming from when the contract is deployed and it has all the gas it needs to execute the init code, but then it runs out of gas while charging for the gas cost related to the contract creation that occur. So yeah, when you deploy a contract, some witness costs, some Verkle tree related costs are charged before the init code is executed, and some are charged after. So this is all in the spec. If the contract creation runs out of gas during that second time that gas is charged, apparently there's a bug. Or at least there's a disagreement on the spec on the interpretation of the spec between Guess and other clients. So we want to keep investigating this one, but I assume it's just a matter of agreeing on when it's to happen and fixing it. And yeah, otherwise there's this on this block 6842, there was a weird interaction in which Guess would charge the gas at the wrong time, and this gas instruction then this the init code would actually, sorry, it's a self-destruct that would actually use the gas instruction to decide where to send the balance. So it's a very peculiar corner case, but it's a valid one. So we found that Guess was charging the gas at the wrong time because of it. So that's great. So this one, yeah, it's not fixed yet, but it's just about charging the gas at the right time. So it will be fixed this week. So that's pretty much it for the bugs. Yeah, like I said, there's no relaunch plan yet, but I think for the relaunch, we would also want to integrate, so fix those bugs, obviously, but we would also want to integrate the change that Kev talked about last time, which is, if I'm not mistaken, instead of serializing the commitments, we would map them to field. Is that correct, Kev?
Yeah, from the outside, you're just still mapping it to 32 bytes. It's just that you're using the group to field or map to field method instead.
Yeah, so I would like to add this when we relaunch. Just want to make sure everybody is okay with it. I don't expect any opposition, but you never know. Okay, well, I guess that's it for the testnet.
Cool. Okay. Next up, we have the proposal for code packaging in Verkle. I believe some folks from Ipsilon, Pavel, as well as Guillaume and others have been discussing this for the past few weeks. Yeah.
Yes.
Pavel, yep. Okay, cool.
Hi, everyone. I think it's my first appearance here. So I think I wouldn't call it proposal yet. It's kind of the exploration at this point. And like the original of this is thinking how can we, what are the alternatives to having this code layout that is currently used in Verkle, which is 1 byte of metadata in the chunk and 31 bytes of actual code. And all of that is needed to be able to have localized jump disk analysis, right? So to be compatible how EVM works. And this document, which is the link is in the agenda. I can resend it to the chat if you want. Yeah, so mostly this document tries to have alternatives which are kind of splitting this metadata and the code into separate sections. To that, we use some small pieces of EOF, but I think the EOF is like the least important part of all of that. So I think conceptually, we try to think what are the other options to keep this metadata somewhere. And this document mostly proposes to have this metadata being proceed the actual code, and there are at least 3 different kind of encodings that we can use. Which one of them is the same as is currently used. So we just move this 1 byte to like separate a section, and the actual code can use like 32 bytes of payload. So whenever you have to verify a jump instruction, you need to reach out to this other section and check if the metadata there actually confirm the jump is valid. Yeah, so we kind of listed 3 different encodings for it. One is a bit set, which a single bit informs that the destination is a valid jump disk. This is more or less how the current EVM works. It just produces this bitmap on the way for the whole code. And yeah, and the other one is to put this 1 byte of metadata in the section accordingly. And the third one is we can actually squeeze this 1 byte into, I believe, 6 bits, because that's enough to have all of that. So this gives us some savings. So in general, this is kind of playing with the trade-off between the actual code size and the computation needed for that. And yeah, I think I'm not fully sure what to do with this next. There are some comments about the document that I plan to incorporate in the document itself. But I think conceptually that's more or less the idea. And I think they come up the question, for example, is it worth it to do it? I think this like two like main benefits of this. One is that the execution is more similar to what we currently have. I think you already know that there will be at least 2 different modes of execution. One is for init code, one is for the deployed code. So we already have like 2 like variants of EVM, and they will behave differently depending on the context. So at least maybe that simplifies the implementation for the execution. And second aspect is that the metadata is actually only needed when you have a jump instruction. So in the current Verkle trees design, you kind of waste this 1 byte of metadata if you fall through from one chunk to the next one and you don't perform any jumps there, because you can kind of figure out the offsets by yourself using the context of the previous chunk. So I'm not sure how to actually simulate the different modes of operation and which one is better, but I think that's for later.
So it was this method, this last point you said, there could be some kind of happy path in which there would be pretty much no jump in the code or as little as possible, and then you would charge less gas because you wouldn't have to go and read the analysis, right?
Yeah, yes. But I think it's a bit difficult to justify that. So yes, so it's not like so strictly it's not like the code size that is actually deployed doesn't contribute directly to the like gas overhead for accessing code. But to kind of to say which one is better, I guess we would need to analyze the execution of existing contracts somehow. I think that's doable, but I think requires some infrastructure to do it. Or you can just launch different tested. I'm not sure exactly how to do it, but you need like kind of dynamic analysis of the execution. It's not enough to just see the code. You just need to know like what are the offsets of the jumps and how frequently they happen, and then we can compare the cost of like different variants of this.
Right. So I mean, not that it's a complete perfect indicator of what future use would be, but we have this code that Ignacio is maintaining at the moment where we replay blocks, historical blocks. We could do this and get this kind of information if we implemented some approach that you describe, which doesn't sound very difficult, well, on paper at least.
Yeah, that sounds really good for analysis. I think if you have something that this proposal can be applied to, I think that would be one of the next steps for it.
Yeah, so unfortunately that code needs to be rebased. Yeah, I mean, I don't know, Ignacio can tell how ready it is, but yeah, we might need a couple of weeks to get it to work, but we could do that. So that's a first question answered. I had another question. Just actually, it's not really a question. It's more like to confirm I understood correctly. You described those three approaches, like the either putting the bitmap or putting the offsets in a section or putting 6-bit offsets in a section. Those are interchangeable. Like if I pick the bitmap, for example, I don't have to store the offsets. Is that correct?
Yes. They differ by like additional kind of computation you need to get the information. Like the bit set is like the straightforward access. You just need to read this one bit from there.
Mhm.
For the others, you just need to do something similar. You are currently doing, which is this. I just call it like localized jump analysis. So mostly perform this analysis on this 32-byte chunk to know where the valid jump tests are in the chunk.
Yeah. And I wanted to make a calculation because the bitmap would be the best. I mean, yes, it's more computationally intensive, but because reading from the tree means increasing the gas cost, if we have to store the bitmap next to it, next to the code, it would be better for us to just store the bitmap. But yeah, one question I had. Sorry, I'm brain dumping here. If the section was that extra section, the jump list section, was spread over several leaves in the tree, would there be any issue with this? I'm thinking of storing the section corresponding to a group of leaves close to the tree, close to where in the tree they are, basically. So that's yeah. I'm just trying to see if we can optimize the gas cost here.
Yeah, I'm not sure I fully understand like the question, but all these jump test sections are kind of random access. So
Okay.
mostly when you need to decide if a jump test in a given code chunk is valid, so for the given code chunk, you need to do a lookup in the jump test section and in a specific offset. So I think in most cases, it means you need additional chunk to load from the jump test section. And whenever this same code chunk will be reused for later jumps, this is up to like checking empirically with the simulation tool. Like how often do we actually reuse the chunk? So the chunk for the bit set, for example, has how many? 32 times 8 code positions, right? So
Right. Mm-hmm.
256.
256.
So, I mean, if you jump a lot within the 256 instructions or like code offsets, that's probably then we use the same chunk. If you jump like a lot with the like big offsets, then maybe it won't. So yeah, I mean, seems to me like this will increase the gas cost, but a bit.
Right.
I mean, it's like, to my experience, it's more likely that the gas cost will be increased with this proposal, but I think we need to verify it.
Okay, cool, makes sense. Yeah, I have more fine detail questions, but I guess I'll ask them offline. No need to. I assume other people want to ask questions, so I'll leave the floor.
Any other questions or follow-up on this? And thank you, Pavel, for giving the overview. If not, we can also continue at async in Discord. Okay. Then moving on to the last agenda item, EIP 2935.
Hey guys, so I have prepared a short presentation to help navigate the discussion, and I'll be presenting it.
Are you able
Just
to?
getting through the mechanics of sharing the screen.
No problem.
Josh, could you share it? I'm not getting the permissions.
Yeah, I just shared it. Oh, you want me to share my screen?
Yep.
Oh, okay, sure. Give me 1 second. Sorry, for some reason it's only letting me share my entire screen, which does not work well. Maybe we can just kind of each go through this document. Do we need to screen share? Is that? Oh, I think we just maybe Gaussian will be right back. Okay, he's back. Did that fix it for you?
Otherwise, I can share.
Yeah, maybe if you don't mind. Just, there we go. Cool. Sorry about that, guys.
Is
We can see.
Gajinder back?
Thought he was.
Oh, sorry, it was muted.
Okay, there you go.
Okay, so this is a short presentation to come up with consensus for moving for the way forward for dealing with block hash. And so the current status is, if you can go to the next slide. So current status is that we have a proposal which says that so we can basically update number to hash on the start of every block. So basically we have a serial storage, and on the fork block we also write the last 256 ancestors so that we can instantly switch to the new logic to resolve the block hash. Next slide. So the salient features of the current proposal are that this is stateless and Verkle friendly, that the accesses in execution witness can help the stateless client resolve the block hash, and there is no weird waiting period. And since this is a serial storage, there is no real wraparound. So perpetual history can be stored since activation, and the block number is not going to wrap around for this particular time, which is quite large, and slot is even bigger. And currently we have this active in constant N4. So we have had two discussions on it in the last VIC as well as last ACD. And the main discussion points are that why it's not a ring buffer like 4788, and what should be the correct implementation method. Should we just do a client native implementation like how it's being done right now, or we should do a system contract? And depending upon what implementation we choose, there are a few things we need to decide upon. Next slide. So the current proposal is for the serial storage, and so the points are that there is perpetual history, but it's still small compared to what the current state is, and offers proving capability against any history trap. There are no wraparounds and simpler logic, and it is resistant to branch poisoning attacks because there is a new branch every 256 slots as per the Verkle logic. But as Ignacio mentioned, it might not be a real problem. And then the second proposal that has been brought forward is that have a ring buffer like 4788. So we might just need 256 slots for the ring buffer. And basically poisoning, since poisoning is not a real reference, and this can just be kept loaded and updated in memory. But even with the serial solution, we can keep last 256 loaded and updated in memory as well. So, and 4788 can be used to construct proofs because they are beacon block accumulators. So you can pick up beacon block header and construct proof against beacon block header because it has the history accumulator, and then you will have to sort of create proof against latest execution block header in the beacon block. So it might be a longer proof, but yeah, it is still possible. So yeah, we'll want to have this discussion that how do people here want to weigh in between these two options. So please give your thoughts.
Yeah, if no one else is talking, I guess I'll start. I think, yeah, the ring buffer might actually be the best option at this point, because I know the state doesn't grow as much as we. Yeah, I mean, this is not going to be a significant increase in the state compared to the actual day-to-day operations of the chain, but it still makes it. It doesn't help. So we have the conversion on the one end, and we have the realization that branch poisoning might not be such a big problem, at least targeting a given branch. Yes, we haven't actually gotten back to Gotti's points, but we should actually try to cover them. But I still think if it takes 10 billions to just slow down the network a bit, I mean, this is what Dunkler was saying. I think it's totally worth it. And there's been a lot of pushback on ACD about not having a ring buffer. I think we could, at least at the beginning, go for the ring buffer. And if it turns out our fears materialize, all we have to do is just keep increasing the count and not use the ring buffer anymore. So there's an easy way out of this problem if it turns out it's really materializing.
Yeah, I would say that it would be useful to like decouple this discussion about branch poisoning with ring buffers. I think it's like still think it's not like the correct framing, because if it is a problem, not using ring buffers won't be really a solution. I mean, sounds like a workaround for block hash, but if branch poisoning is a problem, it's like a much bigger problem in general. And regarding this ring buffer versus perpetual history, I have like a question. Is there like a clear argument on why it is useful to store the history at the execution layer in the tree compared to this other option that is possible today with the beacon accumulators? It's like any like concrete argument on why we need this log history at the execution layer?
I mean, my understanding is that there is none, and that's why the EIP went stagnant.
Cool. Okay.
Yeah, so if we are going for ring buffer, in that case, I mean, what is the size of the ring buffer that we want? 256?
Yeah.
Okay,
Basically, basically keeping the old behavior of block hash.
sounds good. Anyone has any differing views on this?
I have like another question. So I think this perpetual history IP was mostly motivated by, I think like the idea of clients pruning their databases regarding history. Was that like the original motivator for this? Maybe like if there's someone interested in that topic and have an opinion, if like this IP is still needed or something. Or maybe I'm wrong and it's not the original motivation.
I think 4788 had sort of solved that problem. So I guess we don't really need it anymore. All right, we can move to the next discussion point. So what is the implementation method that we should go for? Next slide, please. So basically, the current implementation is that just implement it like a precompile. So client write native code to update the storage, and they resolve the block hash again in the special way. So there is no system contract accesses, and there are no charges, and we can basically keep the gas charge for block hash for what it is, or we can change it to any other static value. So how to explain? So one step behind. And if we are choosing this, then there are two ways we can use to escape the 158 cleanup, which is basically on the fork block we switch nuance of the special address to 1 by doing an irregular state transition, or we can just deploy a get bytecode so that people can also call the contract if they want to from their contracts, or basically block hash opcode can also be resolved natively. So both of so the second part basically can give us two benefits. So if there is a system contract, then it looks like that we are basically we are using our own system for implementing new features, which is sort of elegant, and the gas charges will be per the actual excess of reading them. So basically, the confusion about what is the right gas charge won't be there. But the drawback is that the clients might need to introduce system contract execution capabilities, especially if, for example, there is a special gas pricing that needs to be done over there. And yeah, so the generated address will be used, so there are no 158 cleanup considerations over here. Yes, so please, Wayne, how you feel about this?
I have a question regarding this. So I think this question was also existed in 4788, right? I don't know if someone remembers the argument of why they decided to deploy a contract compared to a client native solution, because it sounds like the same discussion, right? Or it has something different in this case.
Yeah, it is the same discussion in the sense that, first of all, in Beacon block header, I think there was no backward compatibility issue. So it was just like, a new feature that needs to be implemented, even though clients can basically transition can transition execution to this system contract when they want to resolve the opcode. But as such, I don't really have any particular reason for whether we should go for system contract or client native, except the fact that the gas charges would basically be a mess to deal with, or basically we need to figure that part out at least.
Yeah, if I may add to that, the biggest problem was this question to begin with. The fact that we asked the question is that until Verkle happens, or until at least we have witnesses in blocks or available, it doesn't matter what you choose to do. You don't have to call the contract. So, for example, Geth does not, if I'm not mistaken, doesn't call that code. It just updates the state directly. We cannot have that anymore, because if you actually call the code, you will find the code in the witness, or you need to fake the fact that you have called the code, and that's a bit tacky. Or you could also say, well, this part of the code will never end up in the contract, because we expect even stateless clients to have a copy of this code, which is what Matt suggested to me. That can be done, but honestly, yeah, it feels like a special case that's not really useful. And while I don't exactly remember the connection with the reason why they went for this system call, for calling actual code, I sort of get the feeling that this was to be a bit more generic. At least that's what I got from conversation with people. It's just my intuition. Don't quote me on that. But yeah, I think even if we pretend that there was code execution when there is not, or if we do code execution where there's no need to be, we kind of break this purpose altogether. So I think we should actually enshrine. I mean, this is what I would be pushing on ACDE, saying, well, you know what, deploying code was a bad idea. Let's when we switch to Verkle, let's assume everybody has their own implementation, that they go and update the contract, that they don't call any code. That will definitely get some pushback, but I think that's the right choice.
I think for beacon block header, the ring buffer is a bit bigger as well. So here if we only have to store for 256, I think, yeah, we don't really need to do code execution to EVM code execution to serve the block hash.
Yeah, I mean, this point of Guillaume if we have a contract, that means that all the witnesses in every block will have this code, which is somewhat annoying. And yeah, working around that seems like an exception to assume that all stateless clients have the code and don't have to rely on that in the witness is very messy. So I think sounds like a really good argument to maybe try to avoid system contracts in this case if possible. I wasn't having that in my radar. Yeah.
Right. So, and just to add some detail, you actually have to pass some of the data in any case, some of the tree in any case, because if another attack, or actually pretty much the same attack, someone starts inserting values, even if they don't do it on purpose, but there's a new level being added, you need to be able to handle this insertion in the tree. So yeah, it makes things really tacky. Like if you want to omit this approach, omit the fact that like if you want to omit the ring buffer from the proof, you will still need to go through a lot of hoops to keep the tree in the proper shape. So yeah, that's why I would advise not doing it.
Okay, so in that case, in the case that we are going for client native implementation, then what is the best way to resolve 158 cleanup? We do by setting the once to one, or we actually deploy a small contract that can at any way resolve the get calls to it. I mean, even if we won't use it, if someone wants to use it in their contract execution, they're free to use it.
Yeah, so my personal take on that would be indeed to just exactly do what you said, which is just a get, so that other contracts can access that that data if they need it. I don't know why they would do this, but they could. And yeah, it solves the problem of the nonce indeed.
Yeah, so in that case, we'll get a special address, and that is something that we can update in the EIP along with the bytecode for get. Yep, that's all from here. Yeah, thank you.
Thank you, Gashender. That was great. Okay, well, perfect. We got through the agenda. Thank you, everyone, for joining. See you next time.
Thanks.
Yeah,
Bye.
thank you.